read that over and then let me know if you have any questions about it.
Okay. So given two sorted integer arrays, nums1 and nums2, merge nums2 into nums1 as one sorted array. So note is the number of elements initialized are m and n respectively for nums1 and nums2. And I can assume that nums1 has enough space, okay, so greater than or equal to m plus n, to hold additional elements from nums2. Am I allowed to use the existing sort functionality that exists for arrays? So if I were to just add them together and then run a sort on that?
Yeah, so yeah, I mean that would work. That would be not the most optimal runtime I can think of, but that's the only thing that would kind of pop up there would be that nums1 has some extra zeros at the end or something. So, I mean, that would work. You could do the processing to strip it out, but let's try to do it with one pass, so linear time.
Okay. So to do it with linear time, I'm going to have to store some of these that are kind of pieces that I'm going to need and then run some kind of loop over it.
Okay.
So it looks like kind of with that point about the zeros, I'm going to have to be doing some kind of building from the back. So it's important to me where the ending indices of each of these are. And also, given that they're both already sorted, I don't want to touch the beginning of nums1 if I don't have to. So I think it makes sense to start from the back.
Yep.
So do you mind if I just add some comments of just some potential nums1s, nums2? Okay, so for example, if nums1 was just 1, 4, 6, 7 maybe, and then nums2 would be, should probably leave some more spacing in here. Then it was 2, 7, 8. So it kind of has to do some different stuff in here. Okay, that can just kind of help me.
And then just remember that nums1 is gonna,
gonna have at least this situation. You at least have 3 zeros then trailing in the back. Okay. So in this case, then the things that I'm going to want to keep track of is I'm going to want to keep track of where this final 0 is. So call that, I'm gonna just like end of merge is going to start as, and okay, I have nums1 and their lengths and nums2 and their respective lengths. Okay, so this is going to be, in this case, is going to be m. Okay, so this is, is technically like the 3 was index of 3, so I think it's just m plus n minus 1.
Yep.
To start, okay. And then end of 1 is going to be m minus 1. And then end of 2, you can keep my capitalization consistent here, equals n minus 1. Okay. And I think that's all I'm going to need for now. Okay. So since I'm adding since I'm going to be working with nums2 and adding that into nums1, like this is where I have these extra numbers, I want to do something over using this and over nums2, because I want to basically just add these 3 in appropriately. And so it makes sense, I think, to iterate over that. So a while in this case is basically, while this is n minus 1, I have, for example, this 8 selected, and then that would get placed in here accordingly. And then I'd want to move to the 7 and then to the 2. So then while end of 2, and since it could also, since I'm looking at indices, I guess it could also be greater than equal to 0 here. So while that is true, what I need to have some concern over this as well, where I want to have been, in this case, I'm going to have to access these to be able to check their relationship to these here as well. So, and to keep the time down, I'm going to want to use an if here instead of another loop. So basically then end of 1, same thing here, is greater than or equal to 0, I believe, as in I'm checking those pieces as well. I think so basically, if we're in a case where both of these are greater than 0, it means that they both still exist and there's opportunity for either of them to be the greatest number that has to get moved to the end of the list.
Okay.
So in this case, the end of 1, m-1 is going to be 9, and here it's going to be 8. So this is a case where this one is greater. So I think I'm just going to use an and statement in here. So if this is true, and I'm not super familiar, but I think it would be nums1. I think this is how you reference it correctly. So nums1 of, I'm sorry, I forgot the 1. So if nums1, in this case, which is of end of 1, is greater than, which one should I default to if they're equal? Which, does it matter which one is, like, should I always, which array I should put first or last, or does it just not matter?
Let's just, for now, yeah, it doesn't matter. Whatever you want.
Okay.
It won't matter, right? So, because
yeah, because it'll still
it won't matter.
Be sorted order. Okay, so I'm just going to do it in this one because I'm here. So I'm going to say if nums1, so for example, if these were both 9, it'll still follow this piece of the if statement. So in this case then is greater than nums2, end of 2. As I'm telling you here then is if this guy is greater than this guy is what I'm testing here. There's still space and they're greater than. If this is true, what I'm going to want to do is I'm going to want to assign this to 9. And I'm going to want to assign this one to 9 and this one to 8 because it's already sorted. Oh, actually, I take that back because in this case, I'm not going to know if 8 is bigger than 6 or not. So I will not want to do that.
Just focus on one at a time.
Yeah.
For this while loop. Yeah.
Yeah. So for this one, then I will want to add the 9 to the end. So that is at the end of nums. So that's going to, or nums1. So it's going to be nums1 of the end of the merge is going to equal nums1 end of 1. So the 9 will, in my example, will be placed at the end. And after that, since this is going to be filled already, I'm going to want to lower the index to here that I'm going to be replacing and also lower this index down to here so that I'm using like with the 6 instead of the 9 now. So it's going to be then just, in this case, end of merge minus minus, oops, and then end of 1 minus minus. The second one stays unchanged because it has not yet been, we have not done anything to that yet. So then the next case here would be if the opposite was true, where end of 1 is still greater than 0. And this, though, is greater than. So in this case, now, if, for example, if this had gone through the loop and come back, we'd be at still within 8 and 6. So this is basically going to be the opposite. This would still be num's end of merge because that has now moved down an index. So we can continue using that. But this would now be num's 2 of end of 2 would be placed here, followed by the same process here of lowering the end of merge. And then instead this time lowering here. And then, okay, so that would count through here. And then in the case where end of 2, this will stop this inner, or these will stop running when end of 1 then is no longer greater than or equal to 0. So this would be the case where we've moved through the entirety of the list.
Yep.
In this case, or we've moved through this entire list, and we only have whatever is left of num's 1 left. And if it hits this point, is this technically the end? Does anything else?
Well, now that you just might need to just verify that your merge, the elements that your merge index of num1 is, because you're basically using your end of merge as like your iterator, right?
Mm-hmm.
So I think the only thing left to do now is just reassign the location of the nums1 elements so that they fit in your end of merge order.
Okay, so else I then would want to then, if I'm understanding this correctly, then say nums1 of end of merge is then going to equal nums1 just end of 1. Then if there's nothing of n2, just automatically assign the current n to num1 to whatever's currently at the end of num1. Okay.
Yep.
And then continue just iterating down that. And then once we get to the end of, okay, and then that should, I think that, is there, since this is a void, is there anything that needs to be done after the while loop? I wouldn't think so if everything was just being
because we're just doing it all in place of nums1, right? So
yeah,
if it's passed by reference, then we can use it later and it will be all updated for us. So okay, this is good. And then let's see. So now we're just going to talk about the runtime. So what is the runtime of this?
The runtime of this is going to be O of n.
Okay, and why is that?
Because we're going through, or I think, okay, so let me think about for a second. Well, there's only one pass that's happening, so that's what makes we say O of n, but considering what n is in this case would be considering n in this case is we're going through, would it be of m plus n because it's going through all of the elements?
Yeah, I mean, I would accept either n plus n or m, or specifically n, the small n there, just because that's what the while loop condition is.
Gotcha.
But yeah, no, I'd accept either one. So yeah, O of n, and then what about the space?
The space. Okay, so for the space, if what we're adding to already existed in that size, would it not affect the space?
You tell me. So the space complexity is like, added space to get to our solution. So did we have any added space?
I don't think so.
Okay, yeah. So then we get constant space there.
Yeah.
So because we're doing it in place, even if we had like a result array, it would still be, we need that to return. So, so yeah, well, good job with this one.
Thank you.